Alright, so in this video we're going to discuss must-know facts about matrix transposes and the definitions of symmetric and skew-symmetric matrices. So beginning with symmetric matrices, suppose we have some matrix A. We know that A is symmetric when the transpose of A is equal to A. An example of this would be, suppose A is the matrix 1, 3, 3, negative 4. Then taking the transpose of this matrix, where we just make the rows the columns for the transpose. So the 1, 3, the row 1, 3 becomes a column 1 in the transpose of 1, 3. And the row 3, negative 4 becomes a column 3, which is equal to A. Hence, this matrix is symmetric. Alright, now moving on to skew-symmetric. So now suppose we have a different matrix, A. We know A is skew-symmetric when the transpose of A is equal to negative the original matrix. Now another example of this would be, suppose that A 0, 1, negative 1, 0. Well, taking the transpose of this, the rows become the columns. So the new matrix would be 0, negative 1, 1, 0. Now factoring out a negative would have 0, 1, negative 1, 0. And now we realize that 0, 1, negative 1, 0 is just A. So A transpose is just negative A. Hence, the matrix is skew-symmetric. And moving on. So the first must-know rule relates to when we multiply a matrix by some constant lambda and take the transpose of it, how this equals to that constant multiplied by just the transpose, where lambda is any real number. Now the second rule relates to how when we sum two various matrices and take the transpose of them, this is also equal to or equivalent to each matrix transposed individually and then added together. Now moving on, the third rule relates to how matrices are not commutative. So when we multiply two matrices and then take the transpose of this is equal to the transpose of the second matrix multiplied by the transpose of the first matrix. So A times B transpose is equal to B transpose times A transpose. Now a common mistake by many students is to think that it is commutative. So they get their order incorrect and think that when we multiply two matrices and take the transpose, it's equal to the transpose of the first matrix multiplied by the transpose of the second matrix, which is not true. Now the fourth rule, although basic, is very important. So this basically relates to when we take the transpose of a matrix that's already been transposed, it's equal or equivalent to the beginning matrix. So the transposes basically just cancel out. And this concludes must-know facts about matrix transposes and symmetric and skew-symmetric matrices. Thank you.